So hey hi everyone, welcome back to the channel again. So today's GFG today is predecessor and successor from a binary search tree. Okay, so let's read the question first, and then we will understand what does the BST means. Okay, and then we will approach the problem. We will make our approach. We'll discuss the intuition thoroughly, and then we will do the coding part. Right. So yeah, let's back to the question. So we had given a root of a binary search tree and an integer k. Okay. So we need to find the in order predecessor and successor of the given key. Okay. So if either predecessor or successor is not defined, then set it to null. Okay. So we need to find two things: predecessor and successor. Okay. So what does it means is that here in the node it has clarified more. In an in-order traversal, the number just smaller than the target is the predecessor, and the number just greater than the target is the successor. So it simply means you had given a key. Okay, so a number that is just greater than the 65 is the successor of, and that obviously that must be present in this tree. Okay, so the number that is just greater than 65 and is present in this tree will be your successor, and the number just smaller than this 65 and is present in the key will be your predecessor. For example, let's traverse this tree. Okay, so let's first find the predecessor. Predecessor means the largest element that is found in tree that is smaller than this key will be your predecessor. I repeat again, the largest value that is smaller than key and must be present in the tree will be your predecessor. Okay, so yep, let's see. So 50, yeah, it is smaller than 65, so it might be my answer. Okay, then I will move to again let's understand BST once again, because I know most of you forgot what does the BST means. Let me explain BST first, then I will make the approach. Okay, so BST simply means in a tree, for example, this is your parent node, these are your child nodes. Parent is A, child nodes are B and C. Okay, so the BST is similar, like all the properties is similar to your binary tree. I hope you know what is the binary tree. If not, then you can definitely join a link where I frequently connect with the people and connect with for different topics, and yeah, we can have a discussion thoroughly on a particular topic. So yep, so binary tree is similar to so BST is similar to binary tree, but it has one special property. Just you need to remember this special property. What does this property says? The left child of a tree, that is B is the left child. Okay, so this is your left, this is your right, and this is your parent node. Okay, so whatever will be your left child, that must be smaller than parent node. Okay, so from where this node is coming, from where the node is derived, the value of this node must be smaller than the parent node. And what does the other property says? This is your first property, I can say. And what will be your second property? Second property is saying that your right child, it means this node C, the value of node that is equal to C. You can take any value also, like I had taken three variables. You can mark it as 20, and the value of B must be less than 20, let's say 10, and the value of C must be greater than 20, let's say 25. So the right child must be greater than parent, greater than parent. Okay, so this is the property of BST. So how this property, like why this property? So basically this property helps in searching. Okay, so yep, I will just let me know in comments if you want to understand BST thoroughly or binary thoroughly. I will make one series for that too. In fact, you can join our live discussions as well. The link is in the description. You can join there. I will definitely connect and let you know the whole scenarios of binary tree BST, and we can definitely add some more questions. Okay. So yeah, coming back on this question. So we need to use this property here. So I think you get to know what is the BST. BST simply means we while creating a tree, we need to keep in mind like these two properties must satisfy at every node. Let me take a simple example. For example, 50 will be my root node, then the left child must be less than that, right child can be greater than that. Okay, not can be, must be, I can say. It's a property, guys. So it's a if BST means the left child must be smaller than the root node, right child must be greater than the root node. So yep. Similarly, this is smaller than 45 and it can be greater than 45. Similarly, it must be smaller than 65 and this can be, it must be greater than 70. So this is a example of a BST. So yep, now let's come on the question. So it's like, I know this is something off the topic, but yeah, I care that you must know the BST before attempting this question. So it's mandatory. Without knowing BST, you cannot able to do this question. So yep. So now I will help you. Like so, what does the BST says? BST says all my nodes that were present towards my right were greater than me, and all my nodes that were present towards my left must be smaller than me. Okay, so I need to find a value that is just great. Like let's first discuss about the predecessor. What does the predecessor mean? The value that is just smaller than key, but can be a maximum value. As much as possible, it is greater, but it must be smaller than key. Okay, so I need to find nearest smaller value that is less than 65. So yeah, when I started traversing, I will started with the root node. I checked, yeah, 50. Yeah, 50 is can be my answer. It can be one possibility. So I will store in my answer variable. Yeah, this can be my answer. Then I know if I move towards left, all the values must be less than 50. But I had found one answer. It can be like I can take one value that must be that can be greater than 50 but is smaller than 65. So I need to find greater values, right? So as I already told, we need to find the maximum value that is smaller than 65. So in searching maximum value, we will move towards the right. Okay. So after moving right, I observed like the value is 70, but 70 is greater than your key. So this cannot be your precedence. So I know that my answer can reside towards the left of this node. Then I will move to left of it, and I found 60. 60 is smaller than 65. Yep, but it is greater than our previous value. So just replace our previous answer with 60, and 60 will be your predecessor. Why predecessor? Yep, because after reaching to this node, you cannot move towards any node. Okay, so 60 will be your predecessor. Now let's discuss about the successor. Successor means the smallest value that is greater than 65. What is the smallest value that is greater than 65? And obviously it must be present in your tree. So yeah, I started with the root node. I moved to, since I know I need to find the maximum value, right? I need to find greater than 50, in fact 65 as well. So I moved towards the right. I found, yeah, 70 is greater than 65. Yep. So yeah, this can be one possibility. Now I move towards like I want to get the maximum values only. Okay, so I want to move towards right only. So yeah, 70 is one of my answers. I will move to, I can say, yeah, move to right. It came as 80, and it is not, I think, not the smallest value that is greater than 65, because 70 is already the smallest value that is greater than 65. So yeah, this cannot be answer. So 70 will only be my answer. Yeah, 75 will be the answer. Similarly, let's take a quick example. Let me draw that tree and explain you once again. After that, I will move to the solution part. Like my main focus is you understand what's the thing that I wanted to focus on, like what's the intuition I wanted to build for this particular problem. So our key, let's say, is 65 only. So first I need to find predecessor. Predecessor. Initially, I had initialized this with null. Okay, so I started with the root value. So this is my pseudo code for predecessor, whatever will be the spelling, I don't care, but yep. So when I came here at the root node, if I get roots value roots value smaller than your key, okay, then what I need to do, I need to go right. But before going right, just you need to do two things basically. First, update your predecessor. When this condition is satisfied, you need to update your predecessor. And second thing, go to right. Else, go to left. Why left? You understand, na? Like whenever you found a value that is greater than your target means key, then you know if this value is greater than our target, then the answer might be existed in our left way, because it's a property of BST now. The node's value must be, I can say, greater than the left child's data. So the left child's data will be smaller than your root node. So yeah, that's why. So this is the algorithm to find predecessor. Now let's write the pseudocode to find successor. What does the successor say? Successor says the smallest value that is greater than key. So yep, if roots value, okay, if roots value is greater than key, what does this suggest? That this value is greater than successor. Okay, this value is greater than your key. Okay, then simply I will update, like it can be a possible answer, no? I need to find the roots value that is greater than key. When I got that value, I need to update my successor. Similarly, successor also, I will define successor initially as null, and I will update my successor. And what can I do? I will move to left in order to find a better answer. Like since if I got to know like this value is, let's say, 80 or something like that, this value is greater than 65, then I can find some better answer towards the rightwards. Okay. So yep, towards leftward. I can only find my answer towards the leftward because the value is greater than key. So all values that were lesser than key will existed in the left only. Otherwise, I will move to right only. So yep, this is the algo that I need to discuss before writing the code. I hope you understand the question and understand the intuition. Simply I am going to do traversal only basis this condition. If roots value is less than k, I will update my procedure, go to right, else go to left. If roots value greater than k, simply I will update the successor, move to left. Otherwise, I mean else I will move to right. So yep, this is the structure. This is the approach. Let's move to the coding part. So I'm going to take one variable in which I'm going to call one function, find prede. Let's call it prede only as of now. I need to find two values, root and key. Simply I need to store successor in success, and I need to name it as successor only. Okay, I'm going to pass these two values and I'm want to return this only. So this is again a like way of returning things, since this inside curly braces whatever we pass comma separate, that will be part of your vector. So yep, since only two values were there, so rather than taking vector node star vec and then pushing back, so it's the same thing. So nothing to worry about that. It's just a syntax. Okay, syntax in C++. Okay. So yep, since I need to find predecessor and this function must return node star because I'm storing this in a node star type. So yep, I had called. I need these two parameters only in this function as well. Just copied and return. Okay. So I am finding predecessor. So let's define my answer. Predecessor as null, because if I didn't find anything, then I'm going to return null. Then while my root is not null, then what I need to check? I need to check if data, roots data, okay, is smaller than key, then definitely I need to store like if that value is smaller than that value is smaller than key, then that can be your answer. Just store return in a root and move towards the rightward direction, because yeah, there may be chances some better values we can find. Otherwise root equals to roots left, otherwise I will move to left, and at the end I'm going to return pretty this thing only, bro, this thing only. So yep, this is all about finding predecessor. It's a typical simple question. You just need to do whatever the property says of BST. So yep, it's quite simple traversal only. Just read the question, understand the I can say properties of BST, and then just traverse only. So I had taken successor as null, and while my root is not equals to null, I'm going to check if roots data. So if my roots data were greater than key, then what does I need to do? Definitely this can be one. Okay. So if roots data is greater than k, then definitely this can be your one answer, because I need to find a greater value only na, in successor. Then this can be your my answer. I need to and I need to move towards left. Sorry, my roots data is greater than key. Okay, then what does I need to do? I need to move left only. I need to find smaller than values than that can be greater than my target. Then I'm going to took those values as well. Root equals to roots right. This will be my again another thing. Then I need to similarly return this pointer as a successor. And yeah, predecessor successor will be stored in these two variables, and finally we are returning those data. So let's run. I had done some typos. No, success equals to null. Success equals to root. Okay, line number 44. Success equals to root. And node star success. Okay, the function name and this cc successor, let it be called as successor. Anyways, since function name and variable name were same, so yeah, that's done. Again, one thing I had done some more typos, maybe due to, and where is that node star? Successor, find successor. Okay, success is the only name that I had taken initially. So yeah, these are passing my two test cases. So yeah, I hope you understand this logic, and let me try to submit this as well. So yep, it got submitted. Yeah, so this is what the problem about. So do let me know in comments if you face any issues, or if you know if you really want to know more about waste and binary. So I will definitely add that too. And thanks for watching us.